will be presenting solving for advanced mathematics paper. You can follow up on our website at St. Joseph University for more clarity and clarification about the solution of the question papers. Okay, we do have advanced mathematics paper 1 with a total of 10 questions, and I'm going to start question number 1. It's a question concerning a calculator, a programmable calculator. So I just instruct on how to do it and highlight the answers, then I proceed to question number 2. So from question number 1 here, we have question number 1A, which says, by using a non-programmable calculator, evaluate the following. Right, question number 1A, Roman 1. The natural logarithm of the square root of 28.8 times the reciprocal of 0.0067 out of tan square of pi over 3 then cosine squared cube of pi over 4. And Roman 2, it is the tan inverse arctan of logarithm of ln of 26 base 5 out of 7 combination 3 times the cube root of 204.7, and you are told to write your answers from this Roman 1 correct to 5 decimal places. So you can see the issue here is just to plug in these details in your scientific calculator, and then the correct answers for Roman 1, it is 6.2494, and Roman 2, it is 0.00687. And part B was you are given details. You are given a statistical table with the value of x's and the frequencies. 53.8.95. The frequency is 23. The value, second value is 542.95. Its frequency is 55. Class marks and the frequency from your given information, and the third class mark is 546. The frequency was 32. The third one, the fourth one was 550.95. Frequency was 28, and the last one was 554.95. The frequency is 6. And you are told to find the summation of x squares and the mean of the variables and the standard deviation, the sigma subscript n minus 1. So by plugging the details in your scientific calculator, then you could find the correct answers in this part. The summation of x squares should have been 428,14491.96, and the mean for your values was supposed to be 545.255556, and the last one, the standard deviation, had to be 4.401649.052. So these questions, we don't have a lot of things to do here because you just have to know your details and to plug in your scientific calculator. So this, I think we are done with the question number 1 here. So I proceed with question number 2. It's a question concerning hyperbolic functions, and questions here had only 2 sections, and section A and B, and in section B have a particular subsection there. So question number 2A, the question says, solve for these equations: 2 conj x plus sinh x equals to 2. So you are told to solve these hyperbolic equations. That means to find the missing variable x. For what variable x should be here to make this left-hand side part be equivalent to the right-hand side part. So we'll go directly to the definitions of hyperbolic functions. From the definitions of hyperbolic of cosine, which is conj, and the hyperbolic of sine, which is sin. Mathematical definitions of hyperbolic of cosine, which we call conj x, it is given by ln of x plus ln of negative x out of 2. This is the mathematical definition of conj of x. And again, the mathematical definition of sinh of x is ln of x minus ln of negative x out of 2. So again, that one is the definition of hyperbolic of sine, which we call sinh. So then we are going to plug in this, the information concerning conj and the sinh in our given equation there. So you can see we had 2 conj x plus sinh of x equals to 2. So substituting those details of conj x and sinh x in this equation, you're going to have 2 times all what is conj, which is ex plus e negative x out of 2, then plus what is sinh, which is ex minus e negative x out of 2, which is equivalent to 2. Then from there you have to rearrange the equations to have one term with ex and another term with e negative x. Then you could solve more after rearranging for the variable x. So you can see here you have 2 on the numerator and 2 in the denominator, so they're going to cancel out. But here you don't have the 2 here. So this equation means it is ex plus e negative x after cancellation of the 2's, this one and this one. Then plus, this is ex minus e negative x out of 2, which is equivalent to 2. So you can see the arrangement here. We have this function with the denominator here. So we can multiply by 2 throughout the equation so that we can get rid of this denominator 2 here. So multiplying by 2 both sides, and we're going to get 2 times e power x, 2 times e power negative x, then 2 times this term here, 2 will vanish with the 2 here, then 2 by 2 on the right hand side part, which means we're going to have 4 there. So the equations after rearranging is going to be 2ex plus 2e negative x plus ex minus e negative x then equals to 4, because remember we have multiplied by 2 throughout each term from our given equation. So adding the like terms here, you can see you have a term in ex and you have another term in e negative x. So adding 2ex and the 1ex, we are going to have 3ex. I'm saying here 2ex plus ex and 2e negative x minus e negative x equals to 4. I have rearranged this equation. I'm combining this ex with ex. That's why I took 2ex and ex. And then 2e negative x with another e negative x here. So it is 2e negative x minus e negative x here. So you can see we have one term in terms of e power x and have another term in terms of e power negative x. So adding the two terms here, it is like 2 terms plus 1 with a common coefficient e power x, which is going to be 3e power x, and 2 minus 1, it is actually going to be just positive 1 e power negative x equals to 4. So we have a simplest equation, which is 3ex plus e negative x, which is equal to 4. We are looking for the value of x from here. So we are going to multiply either by e positive x or by e negative x, so that we could have a single term with positive x or negative x. So for me, I could choose to multiply throughout by e with positive x throughout the equation. So you're going to have 3 e power x times another e power x plus e power negative x times e power x equals to 4 e power x. You have seen here from these terms, I have introduced term e power x throughout, because I say I'm going to multiply throughout with e power x. So from this first term here, you have e power x times e power x. That you can see e power x plus times e power x, there are two terms multiplied. So it's going to be e power x squared, which you're going to write 3 times e power x, which is 2 times multiplied. So it is e power x squared this way. And this one you can see you have two different powers, e power negative x and e power x. The multiplication rule on multiplying two powers of the same basis but with different exponents, we are allowed to take the common base and add the exponents. So we can do here this way, that this term is equivalent to write e power negative x plus x. And this term here, there's no complication here because we have only one e power x, so it remains as it was. But for here, e power negative x plus x, the summation of negative x and x is going to be 0. So this equation is going to be 3 power e, then 2x, because you can see here, e is the base, but x is the exponent, and the 2 is the exponent. So you can multiply x with 2 to have 3 e power 2x. But in this second term here, you have a summation of negative x and a positive x, which give you 0. So you're going to have e power 0. And on the right hand side part, it's going to remain e 4 power ex as it was. But remember, this term here, it has exponent 0, which means, and we know there is a rule which says once any number on a term is raised to 0, that term has to be 1. Any number raised to 0 has to be 1. So we are going to say this is 3 power e2x plus 1 equals to 4 ex. Then from here we could rearrange the equation to make sure that one side is 0, which means this 4 ex could come to a left hand side part, and the equation is going to be 3 power e2x minus 4 e power x plus 1 then is equal to 0. Then from here you can see you have one equation in terms of e power x only. I'm saying one equation in terms of e power x only because this is not just e power 2x. This is just ex squared. And this is ex. So this is ex and this is ex. It is written e power 2x because of the factor 2 here, which was ex was squared before. So this is e power x then squared. And this is e power x without n squared. So you can see this is a quadratic equation in terms of e power x, because this can be written as 3 power e times e power x then squared here minus 4 e power x then plus 1. If you could assume this variable e power x to be something maybe like a or y, you're going to have a simplest quadratic equation, a simplest polynomial equation of second degree. So suppose if we relate y equals to e power x from here, you're going to have 3, then this is y, it is y squared, and this 4 e power x, it is y plus 1 equals to 0. So you can see this is simply a quadratic equation of second degree that you can solve it by using the general formula of quadratic equation with our coefficient a here. Coefficient of y squared, b here, the coefficient of y, and the constant c, which is free from y. And the rule says the value of y from that equation is given by the general formula from the general formula from that equation. We can get y by saying y is negative b plus or minus the square root of b squared minus 4ac out of 2a, where a, b, and c are coefficients of y squared, y, and the constant term respectively. The coefficient of y squared here, which is 3, is what we call a. The coefficient of y here, which is negative 4, we call it b. And the term which is free from y, it is a constant term which is 1 here, we call it c. So we're going to plug them in this equation to get the values of y. So we're going to have our a is 3, our b is negative 4, and our constant c is just 1. So putting these values in this equation, you're going to have y equals to negative b, and our b is negative 4. So it's going to be negative, negative 4. This is negative b. And then plus or minus the square root of b squared. Our b is negative 4. So negative 4 is going to be squared. Then minus 4 times a. Our a is 3. N times c, which is 1. Then out of 2 times a. And our a is 3. So we're going to have, after simplification here, this is positive 4. Negative times negative 4 is positive 4. So we're going to have 4 plus or minus. The answer here, 4 squared is 16 minus 4 times 3 times 1, which is 12. So we're going to have 16 minus 12, which is 4. And the square root of 4, we know it is 2. So out of 2 times 3, which is 6. So we're going to have 4 plus or minus 2 over 6. That we know, this arrangement of positive or minus is going to give us two different values of y, for positive and for negative. So for positive here, the value of y is going to be 4 plus 2 over 6, which is actually 1. And for negative, the value of y is going to be actually 4 minus 2 over 6, which is 2 over 3. That you can say 2 over 6, which you can simplify to 1 over 3. So actually from that quadratic equation, the value of y is 1, or the value of y is 1 over 3. So you have to remember something. We are not taught to solve for y in our original equation. Our original equation was written in terms of x only. So this y is what you named there. Somebody could name it m. You choose y. So y is not what we were asking. We were asking to find. So we have to know what was y. We assumed y to be e power x there. So we have to come back here to say, but you know y was e power x because we are looking for x. So it means if y is 1, it means even ex is going to be 1 because y is e power x. And ex again is going to be 1 over 3. So we need to find some xe from this expression. E power x equals to 1 and e power x equals to 1 over 3. And the best way to eliminate ln, this constant ln, is to apply natural logarithm. So we're going to say this implies the natural logarithm of ln e power x equals to natural logarithm of 1, which gives us the value of x has to be ln 1. And from this one, e power x equals to 1 over 3, we apply ln of e power x equals to ln of 1 over 3, which means the value of x is going to be actually ln of 1 over 3. So you can see from there you have two distinct values of x. The first one is x equals to ln 1, and the second one, x is equals to ln of 1 over 3. That you can write as negative ln of 3 after disarranging that fraction 1 over 3 to 3 power negative 1. So actually the set of x here is two distinct values, one which is ln 1 and the other one is negative ln of 3. These are the values of x that we were told to calculate from the original equation. So we are done with our part A here. That is the values of x. And here you can simply say this ln 1, we know it is just 0. So x is 0 or negative ln over 3. You can see the way you write, you can choose where to end with just ln 1 or you can put it 0 because ln 1 is mathematically equivalent to 0. So we are done with part A here. So I'm going directly to part B from our paper. A part B, 2B. The question says, generate a reduction formula of I subscript n, which is given mathematically as the integral of tanh power n x dx. And then the question says, and use that result to generate the value of tanh power 4 dx. So what we are given, we are given reduction formula In, which is tanh power nx dx. And the question says we have to generate the reduction formula from this hyperbolic function. And then after that, we have to find the value of tanh power 4x. That means when a specific value of n is 4, what could have been the value of integral of tanh of 4x. So directly we're going to derive the reduction formula for tanh x power n with respect to x. So from In is given by tanh power nx dx. From here, for this function, hyperbolic functions, we have hyperbolic of sine, which is sinh, hyperbolic of cosine, which is conj, hyperbolic of cotangent, which is this one, cotang, and we have hyperbolic of cotangent, which is cot, and we have hyperbolic of secant, which is sech, and we have hyperbolic of cosecant, which is cosec. All of them have different techniques in deriving the reduction formula with power n. So for tanh x and cot x, they have the same technique. For here, you're going to dismantle this power n into two terms. You're going to dismantle that one by 2. You're going to take n minus 2 and then u plus 2. So we're going to dismantle this hyperbolic function into tanh square x times tanh power n minus 2x dx. So this term here, we're going to write it as the integral of tanh of n minus 2x times tanh square of x dx. Have to be very careful here because you can see this is just the multiplication of two details, two informations, two functions, and that is functions of tangent, hyperbolic of tangent. It is tanh and here it is tanh. So you can take tanh and tanh as bases, and the exponents here are e negative 2 and then 2 here. So the mathematical rule of multiplying two different terms with the same basis, you are allowed to add the exponents. So if you are going to take common tanh here and add these two exponents, you see you're going to have n minus 2 plus 2, which is n, which is equivalent to this term here. So you can dismantle this term into these two different terms here. So after that, I'm going to define this tanh square x. This technique that we are doing here for tanh, you can do the same for cot, hyperbolic of cotangent, because the technique for hyperbolic of cotangent is equivalent to techniques of hyperbolic of tangent. Hyperbolic of sine, you're going to do the same thing if you are asked to do the same thing for hyperbolic of cosine. So hyperbolic of sine, hyperbolic of cosine. Hyperbolic of tangent, hyperbolic of cotangent. And hyperbolic of secant to the hyperbolic of cosecant. You can see in naming those functions there is cosine means complement of sine. So cosine and sine, they are related in their details. Even cot, it is called complement of tangent. So cotangent is related to tangent. And even cosecant, cosec is related to secant. So they are related, mathematically related. So what we are doing here, you can do the same thing for cotangent. So we have dismantled this n into n minus 2 and n. That means mathematically it is correct. You can add the exponents of n minus 2 plus 2 to be n, which is the original function was. So after dismantling that exponent, you have to define this tangent square x using hyperbolic identities that we know. But we know that sec squared x equals to 1 minus tangent squared x. So what we need here, we need to define this tangent squared x in terms of sec squared x. So we are going to eliminate this tangent squared x. We are going to write it in terms of sec squared x. So from this definition, this is the hyperbolic identity. It is a common definition in mathematics. So tangent squared x is going to be 1 minus sec squared x. So this is the definition of tangent squared x from our integrand there. So we are going to substitute this tangent squared x in our integrand here. So our in is going to be the integral, this term here, tangent n minus 2x times tangent square, which is now this one, 1 minus sec squared x dx. So you can see the integrand is now changing from tangent square into 1 minus sec square. So you're going to open the bracket by multiplying each term with this outside here, tangent power n minus 2x. So you're going to multiply it. So this in, you have to write here, in was tangent n minus 2 power x dx minus, I hope you understand here, there's minus here, so multiplying tangent n minus 2x times 1 is going to be just tangent power n minus 2x, but this one to this term is going to be tangent power n minus 2x times sec square x. You don't have to forget this dx. This is very important. This is what tells what you are integrating with respect to. So dx, it means we are going to integrate with respect to x. So opening the bracket, you make sure you don't have to forget this term dx, differential of x. So another term here is going to be integrand of tangent of n minus 2x, then times the second term there, that was sec squared x dx. I hope now it's very clear. The arrangement is very, very much clear. But there is something that you have to note here. Mathematics, it's all about patterns. From the first term here, from the first given information, we had I subscript n. You can see very carefully here. There's something important you have to realize here, so that you can do here in our step that you have arrived here. So there is I subscript n here, which is given as the integrand of tangent power n x dx. So this subscript here n is what is here as the exponent. So there's something we're going to do here. In our step here, you can see we're done with this transformation here after eliminating this tangent square x, and we have something here. This something is the integrand of tangent power n minus 2. So you can see here it is tangent power n x, tangent power n x dx. Here it is tangent power n minus 2 x dx. So if tangent power n x dx was called I power n, then you can see how you can name this one. This is tangent power n minus 2 x dx. So what is here as the exponent could be the subscript of the integrand. So we could name this one in on the left hand side part, but this one you could name it as I n minus 2, because what should come here, the subscript, it is the power of the integrand. So the power of the integrand is n, the subscript is n. The power of the integrand here is n minus 2, and our subscript here has to be n minus 2. So you can see you have changed the name here. But the term here will remain the same as tangent n minus 2x, then times sec squared x dx. So you have something to do for this term here, because you have to simplify it, but we are done with this part here. What are you going to do here? You have an integrand here with two different terms. Hyperbolic of tangent, which is tangent, and the hyperbolic of secant, which is sec. So what you're going to do here, if you see an integrand with two different terms, like this one, and those terms are connected in such a way that the derivative of one term could give you another term within the same integrand, it's more likely that solution is going to be solved using a technique of substitution. As you can see here, we have tanh and we have sech squared. Tanh squared, if it is differentiated with respect to x, it gives you sech squared. So you could take that advantage of that format of tanh x and sech square x. You could name a tanh x to be something, and then you could differentiate it to give you sech square. After doing that, after realizing that those two terms are mathematically connected, that way, it is very simple. It will become much simpler to reduce this expression, and then you could solve it even to use a power rule of integration, because you could express this term here in terms of a particular singular variable. So after being confident that the derivative of tanh is sech square, you just name what is tanh. So you have to understand this is tanh power nx. So this mathematically is equivalent to tanh of x bracket power n minus 2. So I could say let maybe u is going to be tanh of x, because I know after differentiating tanh x, I'm going to get sech squared x. So this implies the derivative of u is going to be sech squared x dx. And you can see here, the derivative of tanh x is sech squared x dx, which is here. And this was our objective, to differentiate something that could bring us something that is within the same integrand that we had. So this integrand is written in terms of variable x, and this dx is a differential of a variable, which means you are integrating this function with respect to x. So once you have introduced another variable u, it means you're no longer going to integrate with respect to x from this expression, because you have introduced another variable that wasn't there. So you have to make sure even this dx is eliminated. So this function has to be written in terms of new variable u only now. So you can see sech squared x dx, which is this one, it is now mathematically equivalent to du. So you eliminate sech squared x dx as du, and you know what you did for tanh. You say tanh it is u. So it is tanh power n minus 2. So this is now going to be u power n minus 2 du. So my term here is going to be I power n, I substitute n, equals to I n minus 2 minus, then this is u power n minus 2, and that sech squared x dx is going to be just du. So you can see the expression now is so much simple. As you can see, you have one single variable here that you can integrate it using a power rule of integration, that x power n dx is equivalent to x power n plus 1 out of n plus 1. That's the simple definition of integration. So the output here is going to be yn minus 2 minus u power n plus 1. Our n here is n minus 2. So it is n minus 2 plus 1 out of n minus 2 plus 1. Then plus the arbitrary constant that we always add after integrating, because we didn't know if it was there before differentiating to that derivative, because the integrand is always the derivative. So you have to add this arbitrary constant to make sure that if it was there, because after differentiating it, it's going to be 0. That's why we didn't have it here in our start. So this in is going to be I power n minus 2, subscript, n minus 2, minus, then this is u n minus 1 out of n minus 1 plus the arbitrary constant. But we didn't have anything called u in our question. We didn't have anything called u in our question. U is what it was your name that you named here, for simplification to integrate that function. So you have to make sure you define it back, because it wasn't there. Somebody could use m, could use a, so u is not a formula that you can use, and it wasn't in our question. So you have to define back what was u before. And you can see u here, we called u, we assumed the u here. We assumed u, it is times x. So you could plug in here the definition of u. So your in is going to be in minus 2 minus, then this is u, which is times x power n minus 1 out of n minus 1 plus c. I hope I'm very clear up to there, because I have just substituted the value of u in my equation. So in is going to be I n minus 2 minus. Then this is going to be written as tanh of n minus 1x out of n minus 1 plus c. So this one is what we call the reduction formula of tangent, because even that n was unknown. It was very unknown. You can say even this subscript n is reduced into n minus 2. That's why it's called reduction formula. So if you're going to plug in values here like 4, 5 here, plugging 5 here is going to be 3 here, because 5 minus 3, so it's going to be reduced. Then 3 here you could solve using the same formula, because that is I3. You're going to plug it 3 here, it's going to be 3 minus 2, which is 1. It's going to be reduced more. So you can reduce any power that you have in your integrand as n. If n is an integer, you can reduce it to 0 and solve the equation simply, because that power is too high to integrate using analytical methods. So this is the reduction rule that can be used to simplify hyperbolic functions with any power which is too much great to integrate analytically. So this is our reduction form, our part A. So we had a subsection there which says use the results, which is this one. This is our result. This is our reduction formula. Use the results to evaluate the value of tanh power 4x dx. Okay, so tanh power 4x dx. Tanh power 4x dx. You can see the formatting. If you could compare this one with the original function that was tanh power nx dx, you could see clearly. So it's like the same thing for specific value of n4 now, but you have the result here, so we're going to do the result. So for n equals to 4, I'm going to do that result there, that from my formula, that was I subscript n, which is I n minus 2, then minus tanh of n minus 1x out of c. For n equals to 4, the expression is going to be I subscript 4, which is going to be I subscript 2, because it is 4 minus 2 here. It's going to be reduced into I2, minus, this is going to be tanh of n. The value of n is 4. 4 minus 1 is 3. So it is 3x out of n minus 1, which is 4 minus 1, which is going to be 3, plus the constant c. So we expected, this is I power 4. That was the tanh of 4x dx, which is now I subscript 2 minus tanh cube x over 3 plus c. So what follows here, we expected the answer to be in terms of x on. So you can see there is more i's here, but it is now reduced. So you can continue to reduce more. Or if it is can be simply solved analytically, you can solve it, you can decide to solve the elective. Because if I is 2, you could change this form. With subscript 2, then it's going to have power 2 in the integral. So you're going to write this is the integral of tanh power 4x dx. Then I power 2 is going to be the integral of tanh squared x dx minus, this is just the answer, it's 1 over 3, then tanh cube x plus c. Then you can define tangent square very simply. Tan square or tangent square can be solved very simply, because you just simply express this one in terms of sec square, and then you integrate it simply. So you have to define it. Tangent square, it is the sec, 1, it is 1 minus sec squared x dx minus, this is 1 over 3, this is tanh cube x plus c, because this is the definition of tangent squared x. Why we do this? We do this because sec square can be simply integrated compared to tangent square. So we do this because we know the actual integrand of sec squared x And we know simply the integrand of 1, so we don't have to bother our mind integrating tangent squared dx, and yet we know we can express it simply in terms of other terms that can be easily integrated. So we're going to open the bracket. This is going to be the integral of 1 dx. This is going to be the integral of sec squared dx. This is going to be 1 over 3 tang cube x plus c. The integral of 1 dx is just x, and the integral of sec squared dx, it is tang x, and the answer there was 1 over 3 tang cube x plus c. So this is I power 4. That was actually tang power 4x dx, which is x minus tang cube x plus c. So you can see there we are done with question number 2. So we are done with question number 2. So I'm going directly to question number 3. Question number 3 here. Question number 3 says it's a linear programming question. Question concerning transportation. It was a transportation problem. So it has no subsection. It's just question number 3 alone. So the question says a water supply company has 2 sources. So we have 2 sources here. They have named S1 and S2. So I could name that way. 2 sources, S1 and S2, with capacities of 50,000 liters. This source 1 here has a capacity of 50,000 liters. And source 2 with the capacity of 30,000 liters. This one, source 2, has capacity of 30,000 liters. And the question says that are the details concerning the source of that water supply company. And the company is to supply water to 3 pumps. So we have sources here, and we have destination. That liquid is going to be destined to through pumps. We have pipes here. We have pump 1 that we can call it P1. We have a pump 2 that we can call it P2. And we have another pump P3 that we can call it P3. And what's the requirements? The requirements of pump 1, we have given the sources, the capacity, and the pumps, and their requirements. How much they could hold, how much they could carry. So pump 1, the company is to supply water to 3 pumps, P1, P2, and P3. Both the requirements are 30,000 liters, 20,000 liters, and 25,000 liters, respectively. That means the requirement for pump 1 was 35,000 liters. Pump 2 was 2,000 liters. Pump 3 was 25,000 liters. So this is a transportation problem. So I'm going to draw a schedule for as you always read for transportation problem. So I'm going to have 2 sources here. That is S1 and S2. So I could name this is source S2, this is source S1, and I'm going to have my pumps here. with the requirement that you are going to take waters from these two sources. The first one, the second one here, and the third one here, down. So I have to highlight them, I have to name them. This is pipe 1, this is pipe 2, this is pipe 3. That's going to hold the waters from these sources. So it is the source which is going to supply water to this pump, and then finally to this pump here. And so it's still the same way to pump 1, to pump 2, and to pump 3 downward here. And we have the capacities for source 1 was 50,000 liters, for pipe 2 was 30,000 liters, pipe 1, its requirement was 35,000 liters. Pipe 2 was 20,000 liters, and pipe 3 was 25,000 liters. So these are the sources, and these are pipes. Like these are the pipes that are used to carry water to destinations. So what we are going to do here, from the sources, we're going to introduce variable, the amount of water that was carried to pump 1 from S1. We're going to name it because we don't know the amount. We're going to name it as X. Then we're going to name from source 1 to P1, we're going to name it as Y. And then, because X goes to P1, Y goes to P2, what will go here, it is the remaining amount from S1. So we're going to write it as 50,000 minus the sum that already gone to P1 and P2. So we take 50,000 minus the sum of the two to get the remaining amount that will go to P3 here. And the same thing to S2. The requirement for P1 is 35,000. So what S1 will give here should not exceed 35,000. Should be something less or equal to 35,000. So if if the amount of X was below 35,000, like 20,000. So P1 will be missing 15,000. So those 15,000 liters then will be carried from S2. So you can see what will come here from S2 to P1. It is the main amount that P1 needs to satisfy the capacity of P1. So we're going to write the amount here as something remained from P1 that is going to need to carry from S2. So we're going to write the amount remaining. How could we know the amount remained from P1? Suppose the amount of X was 2,000 liters, and the capacity of P1 is 35,000 liters. So if it would take 2,000 liters, and yet its capacity is 35,000 liters, that means for that case it is missing 15,000 liters. So those 15,000 liters and the difference of the capacity minus what has been put there. So we're going to take 35,000 liters minus what was gone there, what was supplied there before from S1. So this is the remaining amount that P1 is missing, that is going to take from S2. So we'll write it this way. And the same thing, we'll do the same thing for Y, because Y liters is what is supplied to P2. So we don't know whether Y are going to be exactly 2,000 liters. But the amount that should come here as Y should not exceed the capacity, because P2 has to take from S2 and S1. So values from Y1 from Y has to be actually less or equal to 20,000. So suppose if the value of Y was 10,000 liters, it means the remaining 10,000 liters are going to be taken from S2. So the remaining amount is going to be the capacity, 2,000 liters, 20,000 liters minus what was taken from S1. This is the amount that will be taken from S2, because the equation is balanced. And the same thing here, the exact amount that will come here from S2 here, we should take the amount that came from S1, that's going to be in pump 3, and yet pump 3, the amount that should come here this way, from this side, from S1 to P3, should not exceed these values here, because this is a requirement. This is the maximum value that P3 could withstand, could hold. It is 25,000 liters. So what should come here on this way should not exceed this value. So if something would come here less than 25,000 liters, we are going to fill it, we are going to satisfy P3 by taking the addition liters of waters from S2. So the amount here is going to be this value minus this one, which is going to be actually x plus y minus 25,000. Taking this value minus this amount. 25,000 liters minus 50,000 liters is going to be negative 25,000 liters, which is this one. And then the value here minus negative x plus y is going to be positive x plus y. So this is the transportation schedule. But have the information here. We need to know the cost of transportation of this liquid, this water from S1 to P1, from S1 to P2, because these are like locations or destinations. So we don't know how much would be needed to transform to transport this water from S1 to P1, from S1 to P2, even from S1 to P3. They are going to differ because of the difference in their capacity and their requirements. So we must have the details about the cost. So you can see the questions they say the cost of transportation. So the cost of transportation of what in Tanzania shillings from the sources, these two sources to these pipes to the water pumps were summarized in the following table. And you can see here from your question paper that you can follow in this website, you can see the question paper, even the marking guide. From the question paper, there is a table there on the question, under the question, which highlighting the cost of transportation from sources to destination. So you can see from S1 to P1, it is 7 Tanzanian shillings, and then from S1 to P2, it is 60. This one, 60 Tanzanian shillings. And from S1 to P3, it is 30. You can write it here, Tanzania shillings. And then from S2 to P1, it is 30 Tanzania shillings. And then from S2 to P2, it is 40 Tanzania shillings. And again, finally, from S2 to P3, it is 20 Tanzanian shillings. So you can see here, we have the details about the variables which went from S1 and S2. And also we have the cost of transportation from each sources to each pump. So these costs are going to help us to find what we call the objective function. The objective function. It's a function in terms of the missing variables in the y, which is going to tell you about the cost of transportation of your general transportation schedule. And what are you going to do? These are units. This is the cost for each unit. These are units x. This is the cost for each unit x. These are units y. This is the cost for each unit y. I'm not saying units actually. Units here specifically it's liters of water. It's the volume of water. So x liters, each liter is going to cost 7 shillings. Each liter from here is going to cost 60 shillings. Each liter that will be transported here is going to cost 30 shillings. Each liter from this side is going to cost 30 shillings. Each liter from this side is going to cost 40 shillings. And each liter in this side is going to cost 20 shillings. So to get the actual cost here, you're going to multiply liters and its cost. Units, 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 its cost. Then to know the total cost, you're going to add the multiple, the product of the units and the cost to get what we call the objective function. You're going to get the objective function. It's a mathematical function which tells about the cost of transportation of that water. So objective function, you can write here, objective function that is written in terms of as x, fx, y. Fx, y, we're going to write it from this part here. We're going to take 7 times x. From this side here, we're going to take 6 times y. From this side here, we're going to take 30 times 50,000 minus x plus y, plus, in this side here, we're going to have 30 times 35,000 minus x, plus, this is 40 times 2,000 minus y, plus, the last one is 20 here, times x plus y minus 25,000. So this is the actual cost function that tells you how much you're going to use in doing transportation of what liters of water from those sources to pumps. So simplifying those variables there, you're going to get objective function f(x, y). After simplification, you can know you just multiply it and you collect the like terms for x, you collect these like terms for y, and the cosine term. So we're going to have a function of x and y, which is 30x plus 10y plus 285, 0, 0, 0, 0. This is the objective function. So this is our cost for any particular units x and any particular all particular units of y. You're going to know how you could calculate the cost of transportation from sources to those pumps. So there is something here that you need to know. You have to write the constraints of your problem. And I was saying here, this P1 here, these are the pumps which takes waters from S1. So I told you that this P1 can't hold more than 35,000. So with these values of x here, this volume x, this amount of liters from S1, which we call x, should never ever exceed 35,000. So this is always less or equal to this amount here. And if it will be equivalent to 35,000 exactly, it means you're going to take nothing from S2, because P1 could be satisfied in that case. So if x could be this amount, it means you're not going to take anything from S2, because P1 could have been satisfied in that case. So this value of x should not exceed 35,000. So the constraint here we're going to write this objective function, which is subject to. You're going to write this constraint. The first one from S1 to P1, which is always equivalent from S2 to P1. So from S1 to P1, this value x, they should never ever exceed this value. So they are going to be less or equal to 35,000. So the value of x there should be less or equal to 35,000 liters. Or on the other side, because we are talking about the same pump, this value is here. Because what should come here, it is always something, not nothing. It is always something. So what should come here to add up the amount of P1, to satisfy P1, should be something and not nothing. So that's why this variable here, it has to be some amount of water. So we're going to write it, this one is something, not nothing. So if it is something, we are going to write it as something greater than 0 always, because it can't be less than that. So 35,000 minus x is going to be greater or equal to 0. I wrote all here because mathematically this one and this one are equivalent. Taking this x to the right hand side part, it's going to be x is less than 35,000 liters, which is equivalent to this one. So for P1, these two constraints represent one information. So that is one information. So this is constraint number 1. You can say that. And for P2, you can see from S1 we took y variables. So again, this y variable should never ever exceed 20,000 liters. This is the maximum capacity. This is the requirement for this pump here. So these values of y should never ever exceed 20,000 shillings. So we're going to write for pump 2 here that y should be less or equal to 20,000 liters. Or again, from S2, you can write these variables here. They're going to be, after subtracting from the requirement here, to know what should comes out from S2, which is 20,000 minus y. This has to be always something, not nothing. It is something. So you're going to write here as 20,000 minus y. That's be greater or equal to 0. So again, rearranging this equation, taking y to the right hand side part, is going to be equivalent to this one. So they're equivalent actually. So we're going to take one thing. It's actually one part. They are not different. So we're going finally to the last part, last pump, P3, which is very specific, very important. every transportation problem with 3 destinations, from this part, number 3, you're going to get 2 different constraints. So the first constraint here from these variables, they are 50,000 liters minus x plus y, which is always something again, and this which is coming here, is always going to be something again. So for this pump, this one is going to be something, not nothing. Always what should come from source is something, not nothing. So if it is something, it is a particular amount of something. That mathematically you can write it as 0. So it's going to be either 0 or above 0, not below 0. So this one is above 0. So we're going to write there that 50,000 minus x plus y has to be greater or equal to 0, which means after rearranging the equation, this x plus y is going to be less or equal to 50,000. This is constraint number 3. This was constraint number 2. And again, from S2 to the same pump, P3, you're going to have this something, which is always going to be another something, because it is something from S2. So we're going to write it something which is either 0 or above 0. So we can write something mathematically as something which is 0 above, not below. So that x plus y minus 25,000 is actually going to be greater or equal to 0, which implies x plus y now is going to be greater or equal to 25,000 after rearranging the expressions, because this number could go to the right hand side part, making x plus y greater or equal to 25,000 shillings. So you can see now we have actually 4 different constraints. This one, this one, this one, and this one. 4 different constraints. But you don't have to forget, in every linear programming problem, I was very insisting here that there is always something. There is always something. That each variable that is transported from S1, either from S1 or S2 to P1, P2, or P3, it is always something, not nothing, not just 0. So if it is always something, there is no room for that, for those variables, these variables, x, this one, this one, this one, this one, to be anything negative. There is no that room for those values to be negative. It can't happen. So what we do, there is something we call non-negative condition, because we know those values can't be 0. So we restrict this condition that x is always greater or equal to 0 and y is always greater or equal to 0. These are non-negativity constraints. You have to add them. So collectively, you have 1, 2, 3, 4, 5, 6 constraints in our linear programming problem. So the formulation is clear from here, that we have our objective function which is subjected to these constraints. So we can go directly now to draw a table, to sketch a table on this problem. We can go directly to draw a table on this problem. Table of values from these inequalities, and we can also we have our constraints here, and we have the objective function. So we could go directly to you have to present this mathematically using a graph. You have to draw the graph on these mathematical equations to know the corner points. And the corner points are actually the variables that are going to suit your problem. Because our problem here, what we need, the problem, what we need here, we need the cost of transportation. And the question says how the delivery, how should the supply from S1, S2, from the sources, how the delivery could be done at a minimum cost. So this is our function that we're going to plug in a particular value of x and a particular value of y to give you a number, and that number is the cost. So for different values of x and y, because we are going to know them from the graph, for different values of x and y, you are going to know which one could bring the least value, that is the minimum value, and then you could choose that the value of x could be something and the value of y could be something to suit our situation, that we need a minimum cost. So what we're going to do here, we're going to have an objective function here,
I'm going to write again objective function. It is fx, y, which is 30x 10y plus 285 000, which is subject to x less or equal to 35,000, y is less or equal to 10,000, x plus y less or equal to 50,000, and x plus y greater or equal to 25,000, and x, y greater or equal to 0. Those non-negativity conditions. So you could sketch the graph here. I will roughly sketch it so you could follow up when you are on the marking guide to see more. So I'm going to roughly sketch those constraints because this is a line. I'm going to sketch it. This line is mathematically in the graph. We're going to eliminate this inequality signs. We're going to write x equals 35,000, y equals to 25,000, x plus y equals to 50,000, x plus y equals to 25,000, x and y equals to 0. We're going to eliminate the inequalities. So I'm going to sketch here. I'm going to draw this graph. We're going to have here 8,000, 16,000, 24,000, 32,000, and 40,000, and 48,000, 10,000, 20,000, 30,000, 40,000, and 50,000. From this line here, this line is going to be x plus y equals to 50. So its intercept is going to be 0 and 50, 50 and 0. So the points are going to be this point and 50 from here, from this point here. So we are going to have a line here which is called x plus y is 50,000. And for this line again, this one, 25. It is simply x plus y equals 25. You mathematicians, you know. X plus y equals 25, you know. The intercept has to be 0 and 25,000 or 25,000 and 0. So we are going to cross here over here, in the middle here. And 25 here, something somewhere here. So it's going to be these two lines, they're going to be drawn this way. These two lines here. So this one and this one. So the line here, this is x plus y equals to 25, 0, 0. And then we have this line here, which I say it is x equals to 35. 35 is going to be somewhere here. So we're going to cross vertical upward because this is the line of x. The line x, this is called 35,000. You're going to write just a number. And lastly, you're going to have this number here, 20,000, which is this one. So it's going to be too close here, over here. Over here. This is y equals to 20,000 shillings. So have our inequality. So there is something we need to do here. We're going to do the shading. We're going to do the shading. We're going to shade our graph. I did something wrong here. I want to correct something here. So I'm going to draw it properly. This line here, there has to be a line that is passing through here, and that line 20,000 is pass from So this line is y equals to 20 thousandths.
So this is the rough sketch. So you can follow up on our website to see the clear graph on how to draw it. Because if you are doing it, you are going to draw it using a graph paper with dimensions. So, and you're going to do the shadings. You're going to shade the required on the unrequired region. From this constraint here, the question says the value of x. The constraint says the value of x should not exceed 35. So from this line here, we have two regions: the right one and the left one. The left one are the values less than 35. So you can see it is satisfying the requirement of the equation. It says the value of x should be less than 35. So all values of x from this side to the left, they're satisfying this equation. So we are going to shade the unrequired region, which is the right hand side part. Just do the little shading because you don't know what other lines could bring. And about this line, 20,000 should be less or equal. So our line is this one, 20,000. So from this line, which is the y-axis, the value of y above 20 is they are from the line above, below 20 they are from the line below. So we need something below. So you can see all the values of y below this line, they are going to satisfy this constraint because y could be 10, could be 5 or 0. It's going to satisfy this inequality. So the region, the required part for this line is below. So we are going to shade the unrequired one, which is our upward one. Then after that, we're going to do about this line here, x plus y equals to 50,000, which is this one. X plus y should be less than 50,000. So we could test this line from this line here. We have a downward part of the line and upward part of the line. So you have to know which points are going to be satisfied by this equation and which side is going not to be satisfied. So testing this 0, 0, because 0, 0 is one-sided in this left side of the line, because I'm talking about this line here. We have the upward side and the downward side. So for this point, I take 0, 0 because it's the very simplest point to test. And this point will represent all other points below this line. So using 0, 0, putting here 0 plus 0 is less than or equal to 50,000. So you get 0 is less than 50,000, which is very correct. So this line is going to be satisfied by all points below it. So I'm going to shade the unrequired part, which is this one, upward. I'm going to shade the unrequired. Because it's like I'm going to delete the unrequired because it is not there. And for this line here, x plus y should be greater than 25. This line, our line is this one. So you be careful again because you're going to test upward this side or downward. For downward, use the same point 0, 0 because it's very simple. This point here will represent all points below this line will be represented by 0. So if we will know something from here, then we'll know about the counterpart. So solving for 0 and 0 in this equation, it's going to be 0 is less than 25,000, which is, no, 0 is greater than 25,000, which is not correct. 0 is not greater than 25,000. So this is what is unrequired because the constraint that doesn't hold for this part. So you're going to solve actually downward here. So after knowing that, you're going to finalize with this x plus y greater to 0. That means you're going to solve to the required part is x greater than 0, which is the side from origin greater than 0. This is the side which is satisfied. And the side which is y greater than 0 is from 0 to above 0, which is satisfied. So we always say this and non-negative condition. We shade for the negative part of y because it is not required, the negative part of y, and we also shade the negative part of x because we need the positive part only. So even this side is not required. So you can see there. Then now I'm going to shade generally my graph how it was. It was this side was upward this way. And left side this way. And downside this line, it was this way, here, on this side here. On the right side this way, on this side.
and the upper side from this line. So you can see, I could try to highlight the feasible region. This one. This is the region which is unshaded. This region here. Be careful. And this is what we were looking for. What should be the unshaded part? Because all parts, apart from this one, are shaded. So this is what we call feasible region. This is called the feasible region. And you have to identify all of the points, the corner points, A, B. These are the corners of this structure. C, this is D, this is E, and this is F. So it's like from there we're going to have 5 corner points. A point section. This is the Cartesian coordinate system. This is the y-axis, and this is the x-axis. Be careful, because each point will be presented by a value from x-axis, by another value from y-axis. So if you're going to come here, like point A here, you know this line here was 25,000, x plus y is 25,000. So the value of x here is 0, the value of y is 25,000. So you have to make sure you name all the points by its value of x and by its value of y. By its value of x, by its value of y. By its value of x, by its value of y. By its value of x, by its value of y. And those value of x and y are those values that are going to be substituted in this function here to give you the cost for those variables. And yet you know what those variables represent. They represent the amount of liters from source 1 and source 2. So what you're going to do here, you're going to say to draw a table. I'm going to draw you a table here of corner points and the costs. I'm going to draw this table. You can follow up and know. You can follow up from our website for clarity on the solution and the graphs, the drawings, and so far. So we have the corner points here. I could highlight x and y, and what is our function f comma y? That is that one. That x plus 10y plus 285,000, and this is the cost, the output, the answer after solving. So we'll have many points here. Point number 1, it is from the graph 25,000. We have 35,000, comma 0. No. This is not 0,000. From this line here, this is the value of x, the y is 0. From this line here, the value of x is 0, then the y is 20,000. So for this point here, it is that line which is x plus y is 25. So here it is 25,000, 0, and here it is 0, 25,000. Here it is 0, the value of x, but the value of y is 20,000, because this is the line of y-axis. For here, you have to be very careful, because this is the intersection of the two lines. Y equals 20,000 and the x plus y equals to 50. So for this particular point here, the value of y will be 20,000. So the value of x, you will solve simultaneously with this line here. So putting the value of y 20,000 here, you're going to make x a subject, and that's going to be 30,000. So you're going to have a point here which is 30,000, 20,000. So the corner points highlighting the value of x, you have to be very careful. Here you have x-intercept, here you have x-intercept, here you have y-intercept, here you have y-intercept. Here is the point of intersection between the intersecting lines, and here again is this line and this line are intersecting. So you have to make sure you highlight very well these points. So the first point here is going to be 25,000, 0. The second one is 35,000, 0. The third one is 35,000, 0, 15, 0. and 30, 0, 0, 0, and 20, 0, 0, 0, and the last one is 50, 5,000, sorry, and 20,000. So you're going to plug in these points in your objective function, because the value of x is this one, 25,000, 25,000, and the value of y is 0. So we're going to substitute here in this function. The value of x here is 35,000, the value of y is 0 for one of the corner points. You're going to put it here to get the cost. The value of x is going to be 35,000 here and 15,000. The value of x, the value of y, you're going to put it here. You're going to know the cost for this part. And 35,000 as x, 25,000 as y, you're going to put the same here in this function to know the cost. Again, the value of x, the value of y, you're going to put again the same function here to know the cost. So, for this value, 25,000, the function says it is 30 times x. It is 30 here times x, which is 25, 0, 0, 0 plus 0y, which is not there, then 285, 0, 0, 0. The value of x is 35,000, so it is 30 times 35,000 plus y is 0 again, so this part will vanish because y is 0, but the constant term will be there, 0, 0, 0, 0. And again, the value of x here is 35,000, you put here 3 times x. My x is 35,000 plus 15,000 times 10, so it is 15,000 plus the constant term 285, 0, 0, 0. Again, the value of x here, 30 times x, which is 30, 0, 0, 0, plus 10 times y, which is 20, 0, 0, 0, plus 285, 0, 0, 0. And again, lastly, the value of x is 5,000, so it is 30 times 5,000 plus 10 times y, which is 20,000 plus 285, 0, 0, 0. Then the output, they're going to be 3600, 0, 0, 0, then 3900 or 0, 0, 0, then 4050, 0, 0, 0, then 3950, 0, 0, 0, and then 3200, then 0, 0, 0, 0. So you can see what we did here. We have tried to draw, this is a rough sketch, it is not even present, so what you do for more clarity, go to our website and you can see the clear graph and the clear points so that you can know what's going on over here. So, but what's actually going on over here, we all know that these points here are the corner points of this feasible region. These regions have like edges. Those edges are what we call corner points. So each edge is represented by abscissae and ordinate. Abscissae is the x value. Ordinate is the y value. So the value of x for A and y. The value of x for y and for B. The value of x and y for C. The value of x and y for D. The value of x and y for E. And the value of x and y for F. So these are the points. Those corner points, those edge points, these edges. These are the points. The value of x and y, we are going to substitute them in your cost function, objective function, which I have written this way here. You're going to put x here, y here, x here, y here, x here, y here, x here, y here. The same way. You're going to write this way because this is 30 times x, y is 0. 30 times x, y is 0. 35x, 15y. 30,000 x, then 20,000 is y. 5,000 is x, 20,000 is y. Then you're going to know this output. So our question asked it what could have been the minimum cost in this delivery. So these are the possibilities. So we could do that schedule for a particular value of x of 25 and y 0 to get this cost of transportation. We could do this schedule for 35,000 and 0 to get this cost for transportation. We could do again for the amount of liters from S1 to P1, that was X, 35,000, and the amount of liters from S2 to P1, which was y, to be 15,000, to give you this cost, 4 million, almost 4 million. And again, the value of x could be 30,000 and 20,000 to give the cost of almost 4 million again, and 5,000 and 20,000 to give you this cost. So from this cost, you can see there are different possibilities of doing this schedule, of doing this transportation for that company, for that water supply company to transport, to supply its water. So you can say the minimum cost here, it is this one, 3,200,000. So this is the minimum cost. This is our minimum cost. You can see, because this is the least value here. So you can see, you can go direct and say the minimum cost in this problem is 32,000. It's 3,200,000 shillings, because I told you that is the function which expresses the cost. So this is the money. This is the money. So I have to write it when you are given the cost in T shillings. And the problem then said, how should the delivery be done? So we have to go back to our schedule to draw a new schedule with our points, that we know exactly that those points, those details are going to give this minimum value, because this is the minimum possible value that we could embrace to do this transportation, to do this supply of water. So we're going to consider the value of x to be 5,000 and the value of y to be 20,000, so that our cost of running the company is minimum. So we're going to take the value of x. This value appeared at x and y. X is 5,000 and y is 20,000. So you can try to redraw the schedule, and you know how it was before. We had this destination. We had the destination here, and we had this one here. We had the pump, the pump. So water is to this source, to this pump, to this pump, to this pump, to this pump, to this pump. So here the detail that goes in this direction was x, and our x actually here is 5,000. So here it is 5,000 from S1, the liters, from S1 to P1. This is P2, and this is P3. This is S2. The value which came here was y. The value of y, that is 2,000. So it is 2,000 liters. And what comes here, if you remember, it was 50 minus the sum of the two. So sum of the two is 25. So 50 minus 25 is going to be another 25. So it is 25 liters. And what was coming from here was 35 minus x, and x is now 5, so it's going to be 30 liters. And what came from S2 in this side was 20,000 minus y, and y is 20,000. So nothing should come from S2 to go to P2. Nothing should go to P2, because it was a difference of 20,000 minus y, and y is 20,000. So it is 20,000 minus 20,000, which is going to be 0. And again, lastly, this one was, if you remember, we took 25 minus x plus y. So what came here was xc plus y minus 25. So x plus y, it is 20 plus 5,000, which is going to be 25,000 minus 25. So again, you're going to have 0 here. So this is how the schedule should be done. That from S1, 5,000 liters to P1, from S1 2,000 liters to P2, from S1 25 liters to P3. But from S2 only 30,000 liters to P1 and nothing to P2 and P3 from S2. So from up there we are done with question number 3. Then we will proceed with other questions. So we are going to proceed with question number 4. 1 minus 2 negative 1, 2 minus 2 0, 3 minus 2 1, 4 minus 2 2. Then FD, the product of frequency and deviation. In this case, F this is 3 power e to x plus 1. So this is the definition of tangent squared x, cube x over 3 to P3. They are going to differ because of the differ. The formulation is clear from here. That we have our constraints here and we have the objective. What could be the unshaded part? Because all parts, we had the pump, the pump, the pump. So we are going to proceed with question number 4. Number 4, it had 2 subsections, part A and only part B. And part A says you have a table here. You have a table here. The question says you have a table with goals scored by 2 teams. You have 2 teams A and B in a football season, where as follows. So it's a table which shows the goals scored by 2 different teams. So the table is written as this way. It's written this way. We had goals. We had number of goals. We had matches for team A and matches played for team B. So we have these values here. This is team A and this is team B. So you have 0 goals for 24 matches of A, for 25 matches of B, and 1 goal for 9 matches of A, 9 matches of B. And you have also 2 goals, 3 goals, and 4 goals for 8 matches of A, 6 matches of B, 5 matches of A, 5 matches of B, 4 matches of A, and 5 matches of B. This is the information that this is a number of goals scored by team A in the season, and for team B, number of goals. So it's like this means team A scored 0 goals for 24 matches, 25 the same 0 goals. Team B for 25 matches scored 0 goals, and team A for 9 different matches it scored 1 goal, and match B for 9 different matches it scored the same 1 goal. Team A for 8 different matches it scored 2 goals, and team B for 6 different matches it scored the same 2 goals. You can see team A and team B for same 5 matches they both scored 3 goals, and team A for 4 different matches scored 4 goals, and team B for 5 different matches scored 4 goals. The question says, by calculating the standard deviation in each case, find which team should be considered to be more consistent. So the question says, which team between A and B could be considered more consistent? And that information you could know simply by knowing the standard deviation from this statistical data, from this statistical information. Because of standard deviation, it's a measure of how much each distinct value is dispersed from the mean. How much is far away from the mean? It is a statistical distribution. So standard deviation is a number, it's a value which tells how much those values are dispersed. So that means if those different values of goals, the results, in terms of number, it means they are not dispersed compared to the mean. I mean, if values are to the mean, it means they are almost equal to the mean. But if values are far apart from the mean, they are far much dispersed from the mean. So the consistency of a team is actually presented in this case by the numbers of the output of the goals scored in terms of the magnitude compared to the standard deviation. So standard deviation, if it could be higher, it means those results, I mean the number of goals, were very dispersed. That means the results from match 1 was too much different from match 2, was too much different from match 4, and so forth. So that's the dispersion, the degree of separation. So if the standard deviation is small, that means values are smaller dispersed. Values are less distributed. They are less separated. So they are like almost the same. They are like together. So if they are like together, it means they have like the same values. So the same value from this case is like a repetition of what? Of the same results. And if the repetition of same results is what we are looking for, because we're going to look for consistency. The consistency is doing the same thing again and again. So in terms of number, in terms of results, in terms of football matches, it's like to have the same results again and again. So to have, in terms of standard deviation, the team that will have a smaller standard deviation is what will be more consistent, because that smaller standard deviation tells that the results are not separated, too much separated. They are like the same, so it is consistent. But if SD is going to be higher, it means that results from a particular team, the values of statistical information that were presented in this table, they are how much dispersed, they are too far. That means the results, the output is different, which means they are not consistent. They get this result, another time the second result, another time the too much far results, which is different from the previous one. So that is the high degree of dispersion, which means there is no consistency there because of too much dispersion. But the smaller standard deviation entails that the consistency of that match will be higher, because in smaller D tells us that the measure of dispersion of the values is very small. So what you're going to do here, we're going to do for team A to know the standard deviation, team A. So you have to construct a small table here. So we have to know the value of X is the output, the goals. We will name X was 0, was 1, was 2, was 3, and lastly 4. These are like the class marks, but this X is you can take them as this. You can take it. It is an grouped data, and this number of goals is the frequency of goals, frequency of match, how much they repeated playing and they got the same values, 0. So this is the number of repetition of matches, which means it's the frequency. So it is 24 for 0, it is 9 for 1, and it is 8 for 2, 5 for 3, and 4 for 4. This is for team A. So we are going to choose the assumed mean here. Assumed mean, we can call it A. I can choose here, assume the mean is chosen from this table of class marks or values. And this data is like ungrouped data, because these are the values, one which is repeated 9 times, two values which are repeated 8 times. So you don't have to consider them as a grouped data, because we don't have class intervals. So these are like class marks, but you're going to take them as distinct value. So when they assumed mean, you're going to take it from this column. So I could choose in the middle here 2, which is more likely to be the assumed mean. So I could choose the assumed mean to be 2. So I could calculate the deviation, which say it is the value of x minus assumed mean. X is the 0, assumed mean is 2. So x minus a is going to be negative 2. For here it's going to be negative 1. 2 minus 2 is going to be 0. 3 minus 2 is going to be 1. 4 minus 2 is going to be 2. This is the D. And then you can calculate then the column of f of D, product of frequency and deviation. And you can see f and D here is going to be negative 48. Here is going to be negative 9, 0, and it's going to be 5. Here is going to be 8. And you have to know the summation of f of D. This is the sum of the columns, vertical upward. So the sum of the f of D. And then you could construct a column of f of D squared. What is f of D squared? That means this is the product of frequency and deviation squared. So you take D squared, for this case it is 4, D squared is 4 times 24. It's going to be 4 times 24, which is how much? 96, you can see there. And D squared in this case is 1 times 9, it's going to be 9. D squared is 0, that's 0. D squared is 1 times 5, 5. D squared is 4 times this one is 16. And then you could calculate the sum of f of D and the sum of f of D squared. So the sum of f of D here, you can know it is, from our table here, it is negative 44. And this one is 126. So from there, you could now say the standard deviation here, it is given by the square root of summation of f of D squared out of summation of frequency minus summation of f of D out of summation of f squared. This is the standard deviation. And the total frequency here is 50. The summation of the frequencies here. So plugging the value here, this is of f. This is the sum of f of D squared. This is the sum of fd. So you're going to have standard deviation for team A is going to be the square root of sum of f of D squared is 126 over sum of f which is 50 minus sum of f of D which is negative 44 over sum of f which is 50. 44 over 50. Then this is value squared. Then you can calculate using your calculator. You will get 1.32. So this is the standard deviation for tube A. It is 1.32. And again, you do the same thing for tube B. You construct a small table there and check the results. These are frequency, the x, the column f of D, and the column f of D squared. The x's, we had 0, we had 1, we had 2, we had 3 and 4, and then you had the sum of the column vertical after adding the terms here. For team B, the frequency were this one, were 25 for 0, 9 for 1, 6 for 2, 5 for 3, and 5 for 4. Deviation, you could choose again, assume the mean to be 2. So deviation here, sorry, I missed it here. I didn't write the column for D again. So I could wipe out this one. So we need a column of deviation here, deviation and f of D then. So the column for deviation, the deviation is x minus a. So 0 minus 2, negative. Two minus 1 minus 2, negative 1, 2 minus 2, 0, 3 minus 2, 1, 4 minus 2, 2. Then FD, the product of frequency and deviation. In this case, FD, it is negative 50 negative 9, 0, 5, 10. Then f of d square, you're going to square the d, then times f. Square d here, it is 4 times 25, it is 100. Square the d times 9 is 9. Square the d times 0 is 0. Square the d times 5, 5. Square d times 5 is going to be 20. So the sum of f of d square is going to be 134. The sum of f of d is going to be negative 44 again. And the sum of frequency is again unchanged, 50 again. So we have sum of f of d square, sum of f of d, and sum of f. This is the form of calculating standard deviation using deviation. So I've just chosen this one using a should be method actually. So you're going to say standard deviation is going to be actually the square root of f of d square out of f of d, no, summation of f minus summation of f of d out of summation of f, then square. So standard deviation is going to be plugging the value here. This one is 134 over 50. This one is negative 44 over 50 again, square. So standard deviation for B is going to be 1.38. So you can see here now, we have calculated the sigma for A, for team A, and the sigma for team B, the standard deviation. And I say the team that has to be considered more consistent, it is the one which was less standard deviation. So you can see here, standard deviation of B is much greater, of A, of B actually, is much greater compared to standard deviation of A. Because this is 1.38 and this is 1.32. So team A, because of smaller standard deviation, which means their value, their results were not dispersed, were not much separated. That means it scored the same results again and again, more likely compared to B, it is team A because of this smaller standard deviation. So we conclude to say team A we have, because team A is more consistent compared to team B because it has smaller standard deviation compared to team B. So that is the case here. So the team with a smaller standard deviation is what that has to be considered as more consistent, because the deviation, standard deviation, it is simply the measure of dispersion. So if it is the result squared by team A and B, to be consistent, it means to have similar results more often. So to have smaller standard deviation, it means your values, your results are not separated. They are like the same always. So that's what consistent means. So a team that scored similar results of matches, depending on this number of standard deviation which we see here, it was team A compared to B, which has its deviation was greater. So it's like this means the standard deviation for B is greater, which means its output, its results after matches were were deviated much from the mean compared to this one, which means they were deviated very little compared to B. So this one is more consistent compared to B. Then we are going to part B. The part B, we have we are given part B, variance of data which are x1, x2, x3 up to xn is 10. The question says what is required. The question says find the standard deviation of 3x1 plus 1, 3x2 plus 1, 3x3 plus 1 up to 3xn plus 1. So we are given statistical data which are x1, x2, x3, x to xn. Their variance is 10. Variance of this is statistical data, x1 up to xn distinctively. Their variance is 10. So the question needs to find the standard deviation of data which are 3x1 plus 1, 3x1 plus 1, 3x2 plus 1, 3x3 plus 1, up to 3xn plus 1. So you can see the pattern has changed. Each term has 3 times x and you add 1 in each variable. So the question is just simple. You have just to arrange the formula and then you use these details to find the detail that you are asking. So you have to start here. You have given the information. Variance of x's, it is 10. And which means variance of x, we know the form of variance of x, it is the square root of summation of x squared out of number of frequencies minus summation of x out of number of frequencies squared, because it is summation of x squared minus the mean square. So which you can write it as the square root of summation of x squared out of n minus x bar squared, which is the mean. But you have to know what is mean bar. Mean this one, x bar, it is the mean, which is the sum of observation out of the number of observation. So for this subscript x1, x2, xn up to xn, it means you have any number of variables, x's. So we could take x1 plus x2 plus x3 up to the last one, which is xn, then divide by the same number. So we don't have anything to write here because we don't know even the x's. So the value of mean, it is just that way. We can't write it anymore. This is the formula. So this is the mean. And the value of the standard deviation, I mean the value of summation of x squared, you can say summation of x squared, how to write it, they are going to be each x squared. It is x squared, x2 squared, x3 squared, up to xn squared. So be careful. This is the sum of x squared. You have to take each value distinctively. You square it and you sum them. Then you can plug it in these values. If you had them, then you could compute the value of standard deviation. So in what we need now, we need the standard deviation for these new values here. Like we have now new mean, because you can see the values are very, very disarranged. This is the new x, the new x, the new x, the new x. So the new mean, you can call it new mean bar, which is going to be new x1, new x2, new x3, up to new xn, out of what? Out of number of observation. But what was the new one? The new one was this one, 3x1 plus 1. So the new mean here, the new x bar was 3x1 plus 1. Another one, x2, was 3x2 plus 1. Another one was 3x3 plus 1. Up to another one of 3xn plus 1. These are the values of x, new x's. And you can see, it is just the pattern here. What you have to recognize here, you can see in each term there is 3x, 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 3x. So you can just fact out 3 for all x's. And you could simply write, this is 3 bracket, x1, x2, x3, up to xn. This way. And again, be careful. There is 1, there is 1, there is 1 up to n at the last term. So you have to add 1, 1, 1, 1 plus 1 plus 1 plus 1 up to the last term. Up to which term we don't know. It is n times. So it's going to be n times. So it is 1 times n, because n is repeated n times. I mean 1 is repeated n times. So it is 1 times n. So if it could have been 2, we could have write 2 plus 2 plus 2 plus 2 n times. So this could have been 2 times n if it would have been 2, but it is 1. So that's why we have written n times 1, because 1 has repeated n times. Out of the same n, because these numbers of items did not change. What changed is the arrangement. So if here was n, they are going to be the same n, but they are just changing in terms of arrangement. So we're going to have, what you can see here, x1 plus x2 plus x3 plus x4 up to xn is the sum of x's, the original x's that we had them. This one, this way, was the sum of x's. over n. So what we have here are the original sum of x's. So the new x mean is going to be 3, then the sum of x's, plus n out of n. So you can separate, dividing by n in each term. You're going to have 3 summation of x over n plus n over n. You can see clearly there. So the value of new mean is going to be 3 summation of x over n plus 1. And you can see what is this one. This is the original definition of mean. The sum of observation of a number of observation, which is this one. So this is the new mean equals to 3 times the original mean plus 1. This is the new mean. You don't have even to bother your mind. That's the new mean. So now you can go back to find directly the standard deviation. So the variance of 3xi plus 1. I've written xi because the rate of x is here, which you can say is sigma square of 3x plus 1. This is just a notation. There is no x1, there is no x2 here. It is collectively, I've written x here. I've written xi here. It is collectively the value of x's, not x1, not x2, not x3, and so forth. So it is just the standard deviation of the new variable, this format, 3x plus 1. So this formula has to be the same way. Be careful. I've written the formula of variance. The formula of variance. Sorry, the formula of variance don't have this square. This is the standard deviation directly. Standard deviation, not variance. So this is the variance. The square of variance is what we call the standard deviation. So you can just square it to find the variance. But to find the standard deviation, you're going to do the square, not the sigma. Which is the standard deviation, which is going to be without square root, because this is the variance, not standard deviation. It's going to be the sum of x squared over n minus the sum of x's over n squared. So the sigma square, which is the variance, 3x plus 1, is going to be, the sum of x's here are going to be 3x1 plus 1 square, because we are going to square them distinctively, each x's, and our new x is 3x1, 3x1 plus 1, 3x2 plus 1. So the value of x1 square is going to be this one, and this one is going to be 3x2 plus 1 for the second x. This is the new x1, this is the new x2, because I need the sum of distinctive x squares. So each x I'm going to square it and add. So I'm going to add it up to the last term, which is going to be 3xn plus 1 squared. But you have to remember, this is the new data. So I'm going to write it out of n minus, remember this is the new mean, because I'm talking about those new variables. So we had our new mean bar, which we need to square it now, because I'm talking about a new arrangement of data, which are new x's, which are this one. So we need to use the new mean, which we got here, which is this one. So we are going to write here this variance square of 3x plus 1 is going to be actually 3x1 plus 1 square, maybe 3x2 plus 1 square. You can just end there and up to 3xn plus 1 square. Then minus, this is out of n first, because this sum of x square out of the new mean, that was 3x bar plus 1 square. Be careful here. So these are the sum of x square, new x square, because these are x bar, x1 bar, x2 bar, x3 bar, xn bar, sorry. And this is the new mean bar, because this is a new data. We have already done, we are already done there with the original data. So this is a new data here. So I'm going to write here sigma square of 3x plus 1. What should come out here? And what should consider here? Be careful here. Squaring this 3x1 plus 1, squaring this term is going to bring me 9. I'm going to write down two terms. 9x1 squared plus 6x1 plus 1. From this one. And from here I'm going to have 9x2 squared, 6x2 plus 1. And up to the last term here. But here I'm going to have 9x bar square plus 6x bar plus again 1. Be careful. The n is in this first term on, not here. So you can see there is a pattern here we need to not to overlook. We need to see very carefully. So this is 1 over n. This one, 9x square, 9x1 square, 9x2 square are going to appear repetitively for all values of x. So we're going to have 9x1 square, 9x2 square, 9x3 square, 9x4 square, up to the last term 9xn square. So you can simply factor out 9 and write x1 square, x2 square, up to xn square for all 9's and x squares. And come back to 6x1, 6x2, it's going to be that way. 6x1, 6x2, 6x3, 6x4, 6xn. So I'm going to, again to factor out 6 and then write x1, x2 up to xn if. And then after that, you're going to add 1, 1, 1, because each term produced 6, 9. Each term produced 6. Each term again produced 1. So we're going to add 1, 1, 1, 1, 1 up to n term. So I'm going to write 1 times n, which is just n, minus 9x bar square minus 6x bar minus 1. So you can clearly see, dividing by n throughout, this is going to be 1 over n, then 9 summation of x squared, new x squared. Be careful here. I have written this and sum of x's, sum of actual x's, sum of squares of x's, because these are x's which are squared, then they are summed, and these are just sum of x's. So I'm going to write 9 collectively sum of x squared, then 6. Remember there is n here, so it is 6, and this is sum of x's here, divided by n, because n is here up to this n here, up to here, but not this part here of mean. This has no n. So n, you divide this by n, you divide this by n, and divide n by n. So n by n here is going to be n out of n again. Then minus the term which is 9x bar square minus 6x bar minus 1, which is going to be, you can see this term here, it is the mean, the sum of x of a number of observations, and this is just 1. So this is equivalent to 1 over n, then 9 summation of x squared plus 6 mean bar plus 1 minus 9 mean bar square 6x bar minus 1. So you can see I have like terms here, this one which vanish with this one, and the one which vanish with 1 here. You can see there, this term is going to be 1 out of n, and now you have remained with 9 summation of x squared only minus 9x bar squared only. So you have a common 9 here that you can factor out. You have bar, x bar, you have sum of x squared after simplifying this expression. It's actually very simple. You just have to consider this x, 3x1, 3x2, 3x1 plus 1, 3x2 plus 2. 3x1 plus 1, 3x2 plus 1, 3x3 plus 1, 3x4 plus 1, up to 3xn plus 1. You square them and then you add them, you know the new mean and the new arrangement from what I did. From squaring the first term, I got 9, I got 6, I got 1. 9, 6, I got 1. So it's a pattern. And in mathematics, it's all about patterns. So we're going to have the same arrangement, 9, 6, 1, 9, 6, 1 for each term. That's why I concluded writing, factoring out 9 and then taking the x squared, because I know there is 9 in every x squared. So x squared, there is 9 always. So I factored out 9. And for this x, there is 6. So I knew that from this pattern, all x's have x's. That's why I factored 6. Then I summed the x's. And from all 1, 1, 1, I summed 1, 1, 1 n times. That's why I take n, because it is 1 times n. 1 has been repeated n times. So it's simply 1 times n. Then I have subtracted the square of this one, which is 9x bar square. This is 6x bar, and the 1 times 1 is just 1. So simplifying this expression, this is the sum of x's, but this is the sum of x squared. So you have to be very careful on that. So simplifying this sum of x divided by n is going to be this one, which is the mean. So it's going to be equivalent to this term. So they're going to find, because this is negative, this is positive. So they're going to cancel out, and no, there is n here and this n here. So this n is in the denominator. So it's 1 over n times n. It's going actually to be n over n. So it's going to be 1, positive 1, going to vanish with negative 1 here. So actually you actually remain with two terms, this one and this one, which didn't vanish here. So this one with n here and this one with no n here. But there is common 9 here. So you can proceed writing that sigma square of my term 3x plus 1, factoring out 9 there, I'm going to have sum of x squared out of n minus bar square. So you can see the picture. What is this? This is the, okay, this is, squaring out this equation is going to be sigma 3x plus 1. It's going to be the square root then of 9, then sum of x squared out of n minus this one square. The square root of 9 we know actually know it is just 9, just 3. Then square root of summation of x squared out of n minus x bar square. And this we know, this is the formula of standard deviation. The formula of standard deviation for values of distinct values of x's. But we are given the variance of this data. The variance of data is this formula of that square. So if the variance is 10, it means this term here, the variance, this is the standard deviation, and this is the standard deviation actual. So if the variance of this data is 10, it means this one is the variance inside. It is 3 square root of the formula of variance of x. This is how the variance of x is written. So this is the variance of x. 1 over n times sum of x square minus the mean square. This is the variance. And we are given originally it was square root of 10. So simply say the 3x plus 1, the sigma of 3x plus 1 of data that we are written in this format is finally going to be 3 square root of n. So this is your last answer after simplification. So the question was not actually complex. It was just the matter of simplification and knowing what x's are we dealing with and what terms are we dealing with, what terms are going to cancel, and what terms are going to remain. And finally, what are you going to get? Which is simply the original formula, which you have in this detail of variance that was 10. So just plug in there and you find the standard deviation. That was simple like that. So we're done with question number 4. So we're going directly to another question. Question number 5. Question number 5. The question says, question number 5. The question says, number 5, Roman 1. The question needed the definition of symmetric difference of two sets and draw them diagrammatically. Symmetric difference of two sets is actually the set of elements that are found within two sets that have intersected, and the symmetric difference of set is actually the elements that are found in both A or B, but not in both sets. So for two sets A and B, their symmetric difference are values which are found in A or in B, but not in both. So symmetric difference of set difference of two sets are values which are found in either of the two sets but not in both. So it's like you take all the elements but you exclude the intersection. So grammatically you can present them as, for two intersecting sets like A and B, you can draw the Venn diagram. Two sets, let's say A and B. This is set A and this is set B. Symmetric difference of sets, it's all sets, it's all values in this set A and B, but not here. So what we are going to write here we can't do that. In your exam, to shade the required part. So we need to shade the required part here. So this is the intersection of two sets. So symmetric difference of sets is actually the values in A or the values in B, but not the intersection. That's why you need the blank space in intersection, because there is no symmetric difference of set that doesn't talk about the intersection. It talk about the set values in A or in B, but not in both. And mathematically, if you take the difference of two sets, they are written as A intersection B complement. So you take the whole A, then you intersect with the of B. This is not the symmetric difference of sets. It is actually, that is the difference of two sets. Symmetric difference of sets is written as A or B. Mathematically, it is not written that way. Not A minus B. They are written symmetric difference of set A and B. It is actually written A or B, not A minus B. Sorry for that, not A minus B. So that is the symmetric difference of set. So we're going to question number B, which says, using the laws of set of algebra, show that 5B. The question needs you to show that B union A intersection A union B union A union C is actually equals to A union B, this way. So you're going to prove this expression here, set expression. Prove this expression using laws of algebra. So you have to consider here the left hand side of the equation, LHS, the left part, which is this one, which says B union A, then intersection A union B union A union C, this way. So you can go like, you can see the arrangement here. You have union A and B, and here you have another union of A and B. So you could see, you need to disarrange this arrangement so that they would look the same. So B union A, it could be A union B. You could do by property, that is called commutative property. So you can simply read this, you can simply write this one is just A union B without complication, then write intersection A union B and union A union C, this way. And what we could say here, this is the commutative property. Commutative property, because you have interchanged just the position of the sets. And then from there you can see you have two sets, this one and this one. They are intersected, but you can see there is something here. This set and this one are the same. So you could think on the best way to interact these two sets is to find something here that could stand for this set. Again, you take this one and another something that is always a universal set or an interset, depending on this operation here of union, so that you could combine these two sets using distributive law, because you could factor out A and B, but you can't do it because there is just one set here. So you need to add something here that will not change the meaning, the original meaning of the set. So what you're going to do here, you're going to unite this one. You're going to intersect. You're going to intersect this one with the. You're going to unite with the empty set, because if you take a set union a empty set is going to be just that set. So you're going to say this one is equivalent to writing this one is A union B. Then you unite it with kappa, the empty set, because this doesn't change. This is just A union B. It's like A union B, you have united it with nothing. Oh, it's 0, it is just A union B. Then intersecting with another set that is A, union B, union A, union C. So any property that is dealing with kappa and union, you can call it identity law. So from here you can say there is this operation union and this union here. So you can think, you can factor out this A union B. You can just like factor out A union B outside. And then you can remain from here, you can remain with kappa on. But kappa has intersected with the remaining here, which is A union C. You be careful because it is kappa, this is no here, it is not here no more. So from here it is kappa. From here we have remained with A union C. So kappa intersection A union C is going to be this way. But you have to remember the operation of A union B. This is the union between here. Because A union B is united with kappa and A union B is united with A union C. So that's the advantage. That A union B is united with kappa and A union B is united with A union C as it was before. So this one union kappa, this one union this one. So it is very clear that it is mathematically equivalent to the previous one. So this is called the distributive law. Because distribution is all about opening the bracket. So even bringing back from the brackets, it is called the distributive. So you can see this side is intersected with kappa. Kappa is within this one, but this one is not within kappa. So intersecting anything with kappa, you're going to remain with kappa because kappa is here and is also here. The intersection is the common value. So kappa here and here, anything it has kappa as its subset. So there is kappa here. So and kappa here. So what could intersect only for these two sets is only kappa here and kappa here. So you're going to say this is A union B union the output here is just kappa. Then if you write the corresponding law for this property. So A union B uniting with something is going to be just the original set, which is A union B, because you can't unite this one with nothing. So set uniting with something which is 0, which is nothing, is going to be just the set. So the output is going just to be A union B, as that we will ask you to prove. So this is the proof here of our expression. And then we have another question here. It's a word problem. It's a word problem. The question says, in a class of 30 students, so we have a class of 30 students. The question says 15 are boys and 15 are girls. A survey showed that 20 pupils studied science and 14 studied maths, but 10 boys studied science and 10 of the boys studied math, but 8 of the boys both studied science and math, and 4 of girls studied neither science nor math. How many pupils in the class studied both science and math? You can see it's very challenging. Did I forget something? And you can see it's very challenging here. You can see you have girls, you have boys, and yet you have math and you have science. 2 subjects, 2 classes, and then 2 classes. So what we need to do here, we need to construct this Venn diagram of these 2 sets here. We have boys, we have girls, but they are like divided. We have some boys who are studying science and maths, so you have to divide it that way. Then you're going to decide, maybe this could be math, and maybe this could be science. And you could say the other part maybe could be boys, and you could divide the lower part could be for girls. Then you have to feed the information. The class say, the information says the class had 30 students. So all of this information, the totality of them, it is 30. There were 30 students. But 15 were boys. So the number of boys here in this part here were just 15. And the number of girls, it means there was 15 because the class had 30 students. So if you had 15 boys, it means the remaining 15 girls are girls. So the question says, a survey showed that 20 pupils study science. 20 pupils, they are trained in this part. So we don't know whether girls, a collection of boys and girls, they are trained. And so we can't write it proper. But also the detail says 14 start math. So we had number of students who take science, they are trained. Number of students who are taking math, they are 14. But the question says 10 of the boys take science. So we have a particular number of boys, because the boys are this upper part, they are taking this part, they are taking science. But you have to know, you have something here, you have the intersection, so you don't have to bother your mind writing 10 here directly, because you don't know what the information is here. So you can name this is X and this is Y, the intersection, because you don't know much about the intersection. So if 10 boys take science, it is this small part, small cycle. Because boys the upper part, and 10 boys are taking science. So you're going to name this, all these are 10s. So if you have named these are X, which are now, this is the remaining one, 10 minus X. And another one, 10 of the boys start math. Again here, this is the side of math, but we don't know about those who are studying both science and math. So we're going to take 10 minus X again here, because 10 boys math, 10 boys science, but we don't know number of those who are taking both math and science. And again, 8 of the boys start both science and math. So you can see the value of here, the value of X here directly. The value of X, the number of the boys who can take both math and science, they are 8. So you can say the value of X is just 8. The value of X is just 8. So this value here, it is just 8 directly. We have it. I was worried that we didn't have it, that we need to solve before knowing that. So if this is 8, it means this, remember this was 10 collectively. So here it is 10 minus 8, which had to be 2. And this is 10 minus 8, which has to be again 2. So, and what follows, the question says 4 of the girls study neither science nor math. This is the set of the girls. So 4 guys they are not here, nor here. They don't do anything. They don't study math, they don't do science. So we're going to write them here because they are just 4. And the question says, how many pupils in the class study both science and maths? The question says, how many students in the class are studying both science and math? So you can say here, for the case of how many boys are studying studying both science and math, you can look at the part here, this part of number of boys. Number of boys, there are 15, number of girls, there are again 15. The question says, how many people in the class study both science and math? And we don't know about these details of here. Number of girls who are taking math on, number of girls who are taking science on. But you can see there's the information there. The number of science students were 20. So if number of science students were 20, you can know if the number of science students were 20, and yet science students for boys were only 10 here. So it means if all students taking science were 20, and yet all students taking science for boys were 10, it means 10 girls were studying science. So this part here is going to be 10, but minus y, because we don't know the number of girls who are taking both math and science. So this smaller cycle here is going to be 10 for girls who are taking science, but we don't know the number of those girls who are taking both science and math. And again, you have another information here, number of mathematics students, there are 14. Mathematics students are this whole set here, but for the other part here, it's for boys, and we were told it was 10 before. So if the number of boys who are taking mathematics is 10, then the remaining number is 4 for girls. So we're going to write here 4 minus y. So we actually don't know the value of y here. So we have to add this number 4 plus this plus this plus this is equal to the number of all girls, which is 15. So we can just take Now 4 minus y plus 10 minus y plus 4, it has to be 15. So this and this vanishes, and this is 14 and this one is 18. So 18 minus y equals 15. So y is going to be actually 18 minus 15, which is there 3. So the value of y is going to be 3. So you can see the number of guys who are doing both. They are 3. So you can redraw even the set, saying that this was the separation, this was the math, this was the science. And here is 8, now it's 2, it is 2. The value of y is now 3 here. Here it is 4 minus 3, 1, 10 minus 3, 7, and yet this is 4. So now you can know. This is math, this is science. This is boys, this is girls. So the question says, how many pupils in the class study both science and math? Which is the intersection here? Both. 3 girls both, 8 boys both. So it is the correction of them, which is 11. So you can write there. Someone so many look at it. Tendrá que yo. Depende de lo que me expliquen para mi reflexión. Jonathan. Okay, so I'm sorry for interruption. So the question says the number of pupils who are taking both science and math, which is the intersection 8 and 3. So the number of students or pupils, they say pupils, who are taking both science and math, where 3 girls plus 8 boys, which are 11 pupils. So the answer was 11 pupils.